Hey everybody, Mr. Covey here, and I'm going over the Unit 7 practice test. Okay, this is one video going over the whole thing. Okay, so I hope you kind of read this already, and you're just here to get some answers because I'm going to go through this relatively quickly. So I'm just going to explain some parts, assuming that you've already tried the problems. Okay, so we got Lemke's rug design, and we got my rug design, and both of them are following a pattern. And what this first question is asking us is basically just to continue the pattern. Okay? So you can do this by drawing the number of stars on a new rug of size 4, 5, and 6, or you can think about it like a sequence. Okay? I like to think about it as a sequence. So if you looked at the number of stars in Mrs. Lemke's rug, size 1 had 3 stars, size 2 had 5 stars, and then size 3 had 7 stars. So looking at the number of stars, it's definitely following a pattern. Okay, so you could draw those different size rugs if you wanted, or you can kind of just look at the number of stars and think, oh, well, wait, for size 4 and size 5 and size 6, I'd have 9 stars, 11 stars, and 13 stars, because it's just going up 2, the number of stars each time. Okay? I'm going to do all the problems with Mrs. Lemke's rug first, and then I'm going to go back and do the problems with Mr. Covey's rug. Okay? So I got this pattern here for Mrs. Lemke's rug. First question, now we have the pattern, is to write a recursive formula. Remember, a recursive formula has to have 2 different parts. The one part tells you where the pattern starts, and the second part tells you how to continue the pattern. Okay? So where does this pattern start? It starts at 3. You can use any letter you want, but I'm going to say A sub 1 equals 3. The second part tells you how to continue the pattern. So the pattern goes up 2, up 2, up 2. The way to write this is to say to figure out any term in the sequence. You look at the term 1 before, you add 2. This is that recursive formula. Okay. Remember that this n-1 here just means that you're looking at the term 1 before to figure out the next term. So to figure out the 10th term, you'd look at the 9th term. You don't actually subtract 1 at any point in time. That's just the notation there. It needs to look exactly like that. Okay. Now, if I want to write an explicit formula for Mrs. Lemke's pattern, okay, it helps to think about whether it's arithmetic or geometric. And looking at it, it's going up by the same amount. It's arithmetic. There's a common difference adding to every time. So when I go to write my explicit formula, once I know it's arithmetic, it's going to look like this. Definitely something that should be on your note card. Okay? I'm going to fill in the different parts. A sub n is going to stay A sub n because it's a formula. I'm still going to have an n. What I need to fill in for is the first term and the common difference. What's the first term? 3. What's the common difference? 2. This is my explicit formula. Okay? Make sure you identify whether the pattern is an adding-subtracting pattern, it's arithmetic, or whether it's a multiplying-dividing pattern, in which case it'd be geometric. Okay, that'll help you write the right formula. Okay. Next question says, hey, now that you have this explicit formula, how many stars would be on a size 14 star rug? I'm not going to just continue the pattern up to 14, because I got this cool formula. I'm going to figure out how many stars would be on the 14th rug by plugging in 14 for n. Toss that all in your calculator. You should get 29. The 14th term in the sequence is 29. There would be 29 stars on the rug. Okay. Next question, be careful about this one. This is a little tricky. It's saying, she made a rug that had 59 stars on it. What size was it? So she's telling you that 59 shows up somewhere in the pattern. She's asking you, where does it show up? How far down the pattern does it show up? I'm going to use my explicit formula again, only I'm not going to plug in 59 for n. I'm not trying to say how many stars are in the 59th size. I'm trying to figure out n. I'm trying to figure out what size gives out 59. So I'm plugging 59 in for my a sub n, and I'm solving for the size. I'm solving for n. If you want to go back to your explicit formula and keep track of the fact that what n is in this formula is the size of the rug, and what a sub n is the number of stars. That might be helpful. Okay. I'm going to solve this equation. Lots of ways to solve this. I'm just going to solve it one way. You guys know how to solve a linear equation. Distribute. Combine like terms. Subtract 1 from both sides. Divide both sides by 2. I get that a size 29 rug would have 59 stars on it. Okay? Cool. Okay, let's go back and do the same questions for my rug design. Okay, so my rug design, following a pattern again. You can draw out the patterns, or mine's kind of big, so it might just be helpful to write down the number of hearts. Okay, so let's slide over and think about it. First one had 3 hearts, then it had 6 hearts, then it had 12 hearts. If I continue that pattern, it's not an adding pattern. This time it's a multiplying pattern. What am I multiplying by? Times 2. So the next rug would have, this is size 1, size 2, size 3. A size 4 rug would have times 2 again, would have 24 hearts. A size 5 rug would have 48 hearts. And a size 6 rug would have 96 hearts. Okay? You can draw them out if you want, but 96 hearts kind of a lot to draw out. That's why looking at the numbers and continuing the pattern that way is helpful. Again, this is a multiplying pattern, not an adding pattern. Okay? Okay. Moving forward, asks us to write a recursive formula. Remember, our recursive formula has 2 parts, a starting amount and a way to continue the pattern. What's the starting amount of hearts? I'm going to use T for this one. Starting amount of hearts, 3. What's the pattern? How do I get the nth term? Well, I take the term 1 before it, and I multiply by 2. There's my recursive formula. Make sure you have both of those parts. Okay? Moving forward here, next part here. This is the hard part. It says write an explicit formula. Now, since this is a multiplying pattern, the explicit formula, the type of sequence it is, rather, is that it's a geometric sequence. So when I'm thinking about writing an explicit formula, it's going to follow this type of pattern. Make sure you have this down on your note card. Okay. If I look at my pattern, remember this is my pattern. If I'm trying to write my formula, I'm still going to have an a sub n. I'm still going to have that n minus 1 there. Those are going to stay. What I need to put in the place is a first term and a common ratio. What's my first term? 3. What's my common ratio? 2. There's my explicit formula. Okay? Okay, so this next part's asking us, now that we have our explicit formula, to actually use it. It says, how many hearts would be on a size 14 heart rug? So they're telling us the size, they're telling us n, and they're asking how many hearts would be on it. Okay, so I'm going to plug 14 in for n. Type that into my calculator for sure, and I get that the 14th size rug would have 24,576 hearts. Seems like a lot, but with that doubling pattern, remember, it just grows really, really, really fast. Yeah. If you're confused about this, it might be helpful to label our equation, kind of like we have for the other one. Here again, n is what size rug we're talking about, and a sub n is the number of hearts. Okay. Next question coming up here is the trickiest question, I think. It says, Mr. Covey made a heart rug and it had 768 hearts on it. What size was it? Okay. So in this problem, they're telling us the number of hearts and asking us the size. So when we take our equation here, they're actually telling us a sub n. They're telling us there's 768 hearts, and they're asking us the size. They're asking us to find n. This equation is a little bit tricky to solve. This is going back to our exponentials and logs unit, but you guys can definitely do this. Okay, I got to get the n by itself. How am I going to do that? Well, first I got to get this exponential part by itself. I got to get rid of that 3 out front. Since I'm multiplying by 3 to get rid of it, I'm going to divide by 3. Okay. Get 256 equals 2 to the n minus 1. This is an exponential equation. I'm solving for an exponent. So my next step is to flip it into log form. If you don't remember how to do this, you should definitely put this on your note card. Yeah, my base is going to be 2. The n minus 1 is going to go over here, and the 256 is going to go here. Remember, you got to type this in your calculator. Make sure you remember how to type that in your calculator. And I get 8 equals n minus 1. Add 1 to both sides. I get n equals 9. What that's telling me is that it's a size 9 rug would have 768 hearts on it. Okay. If you want to remember how to flip between logs and exponentials, here's a reminder. If you have this log, it becomes this exponential equation. Okay. That would be a good thing to put on your note card. Okay. All right. Now there's a couple more questions here that are just kind of general questions, not about the rug design. This one says, one of the patterns is graphed below. Which pattern is graphed? Now, if you look at this graph, the type of graph it is, well, it's not a line, it's exponential. Okay? And if you have a graph that's exponential, that means it came from a geometric sequence. Why? Because geometric is the one with exponents. Think about that explicit formula. It has exponents in it. So the sequence is going to look exponential when you graph it. That's exponential growth in this case. If you look at R2, Mr. Covey's is the one that's graphed here. If we wanted to give a little explanation, we'd say Mr. Covey's pattern was geometric. So it matches an exponential graph. It'd be good to have in your head the idea that exponential and geometric go together. Exponential and geometric go together, and arithmetic and linear go together. Okay? All right, sliding down here. On the other hand, which pattern would better be described as arithmetic? That'd be Mrs. Lemke's. Why? Because it was going up the same amount every time. It wasn't multiplying by the same amount. It was going up. It was adding the same amount every time. You could also say, sorry, give me a second. There was a common difference. It's another way to say it was going up the same every time. Okay? Last question, which rug design is prettier? Mr. Covey's. Why? He has better taste than Mrs. Lemke. That's just a fact. Okay. Make sure you had something down like that. All right. Thanks for watching this. Study for the guest.